Question 3.38. A hollow spherical conductor with a 5 cm radius has a surface charge of 8 nanocoulomb. What is electric potential 8 cm from the center of the sphere? So you have a hollow spherical conductor of radius capital R, which is 5 cm. You can also write this as 0.05 meter. And it carries a charge Q of 8 nanocoulomb, which can be written as 8 times 10 to the power negative 9 coulomb. In the first part, we need to find what is potential 8 cm from the center of the sphere. 8 cm from the center, that means this point lies outside the hollow spherical conductor. And for any point which lies on the outside, you can treat the conductor as a point charge and apply the rule for electric potential due to point charge to find its value at V. So V due to a point charge is kq over R, where k is Coulomb's constant, q is the charge on the conductor, R is the distance at which we are finding the electric potential. So we write this as k is 9 times 10 to the power 9, charge q is 8 times 10 to the power negative 9, distance R is 8 centimeter, which can be written as 0.08 meter. Solve this to get electric potential to be equal to 900 volt. Next, we need to find what is potential 3 centimeter from the center of the sphere. 3 centimeter means it lies within the hollow conductor. And we know for any hollow conducting sphere, electric field inside the conductor will be equal to 0. Electric field is also defined as E equals negative dV over dr. If electric field inside is 0, that means negative derivative of potential is also equal to 0. If derivative of potential is 0, that means potential inside the conductor has to be constant. So at any point inside the conductor, value of electric potential remains constant, which is equal to its potential on the surface. So I can find electric potential at a distance r2, which is 3 centimeter, to be equivalent to electric potential at the surface, which is at a radius r. Because inside the conductor, potential remains constant. So potential at a distance r can be written as kq over capital R. Again, k is 9 times 10 to the power 9. Q is 8 times 10 to the power negative 9. And the distance r is 5 centimeter, which is the radius of the hollow spherical conductor, which is 0.05 meter. And when you solve this, you get potential at a distance of 3 centimeter to be equal to 1440 volt. Next, in part C, they want you to find potential at the center of the sphere. The center also lies within the hollow sphere. And as we discussed before, electric potential at any point within the hollow sphere is constant. So whatever value you had at 3 centimeter, at the center it would be the same. So potential at the center will also be equal to potential at a distance of 3 centimeter, which is 1440 volt. Now, if I were to show a graph of electric potential as a function of distance r for a hollow conducting sphere, let this be the radius of the sphere. Inside the sphere, the potential remains constant. It is not changing. It will be a fixed value. And outside, it decreases as 1 by r. Whereas if you were to plot a graph of electric field versus the distance r, electric field inside a hollow conducting sphere is 0. So there is no field here. Outside, it decreases as 1 by r squared. So just by looking at this graph, you should be able to understand that if they asked you to find electric potential at any point inside a hollow spherical conductor, it has to be a conductor. Electric potential at all points inside is a constant, which is the same value as you obtain on the surface of the conductor.